Okay, so we wrap up our common vector formats with the discussion of the geodatabase. So I'm going to jump into the lecture here. And actually, I want to sort of caveat this because I list this as a common vector format. But one of the things you'll notice down here is that rasters can actually be stored in what I call the canister. So this is what it's going to look like in our catalog, in ArcMap, as you're adding data to the map. And so while a lot of vector data gets stored within geodatabases, rasters can also be stored. So that might be a bit of a misnomer on my part, but typically what we do is we classify it as a vector format. So when ArcGIS came around in the, as I mentioned earlier, the 1999-ish time frame, 2000, they created this new format called geodatabase, which has a lot of power, lots of functionality that we don't necessarily expose you to in an intro to GIS class, but it merits discussing at least on a basic level, and also understanding that you're going to have a lot of data that you might work with that exists in a geodatabase. So the second point here about used with both desktop and enterprise GIS, we're working in the desktop environment, but when we say the term, when we use the term enterprise GIS, or when we use the term enterprise system, essentially what we're talking about is a larger organization, maybe a municipality or an agency that has several different databases that talk to one another, and they may potentially be geo-enabled. So an enterprise GIS system might be one like Baltimore County, for example, has a permitting department. They have a Department of Environmental Protection department. They have a public works department. So all of these different departments maintain their own databases that may have some sort of spatial component to them. And so geodatabases allow for those to be connected and visualized and mapped and analyzed. We're keeping it within the desktop environment, though, here within the context of this intro class, but it is important to understand that larger relational database management systems, which we'll actually mention in the next couple of slides here, are part of enterprise GIS systems that geodatabases can also interact with. So the third point here, of course, other vector formats, shapefiles, coverages, DWGs, and even rasters can get imported and put into the geodatabase. And so this is a nice, neat canister of data that allows us sort of to store all of our things, all things geography, if you will. So when I say all things geography, I'm defining the geodatabase here. And so what we see as layers in the actual map are what we call feature classes. Okay, and so our feature classes are going to be our points, lines, and polygons. They might be other layers, other types of information, but typically our points, lines, and polygons are what we call feature classes, and we might even refer to shapefiles as shapefile feature classes as well. Sometimes they are. You'll notice that I also have feature data sets. There's a couple of different reasons why you would put your GIS layers into a grouping within a feature data set. In some cases, it might be because it's themed data for a certain specific area of the world. For example, the geodatabase that I gave you all for assignment number 2 contained 2 feature data sets, one for the USA and one for the world. So you had the choice to use either one of them. But you also put data, your GIS layers, into feature data sets also because you may be modeling some sort of behavior. And that's some of the stuff that I've actually mentioned here towards the bottom, where we talk about topologies, networks, relationship classes, behavior that you can model in to protect the integrity of the data within your geodatabase. And I'll talk a little bit more of that a little bit later. Attribute tables, again, what I call flat files that may get attached to or used to create new GIS data can get stored within a geodatabase. Again, rasters can get stored. Topologies, we're going to define what topology is here in the last slide, and we'll talk about how these different file formats that we just discussed, some of them have topological rules. The geodatabase has multiple topological rules that are available to you, and we'll talk about, again, what topology is and how some of them have no rules. Networks, relationship classes, these all have to do with how you're doing analysis, for example, on a pipe network of gas or electricity. You would model your data as a network to indicate where things are supposed to connect and where they're not supposed to connect, and where the flow of something like water or gas or electricity is supposed to go. Relationship classes deal more with connecting the spatial data to other flat file tables, for example. So these are all examples of the types of things that can exist within geodatabases. We get into that more within our intermediate level courses. The geodatabase is the cornerstone of our intermediate GIS class, but just understand that at this intro level we don't necessarily get into all of that, but we do distribute data, we do use data that is in the form of a geodatabase. So a geodatabase is a store of geographic data, as I mentioned in the previous slide, but the data itself, the attribute data, is stored in some sort of relational database system. When we talk about enterprise, large organizations, large agencies having an enterprise system, they would choose something like Oracle or SQL Server. I do have the etc. in there. I believe Informix is another example of a relational database management system that might connect to your geographic data that is in the form of a geodatabase, again pointing to the canister here. Microsoft Access, though, is a familiar database program that is used as a database to store data, again, in rows and columns, which can then be connected to our GIS data. And it's important to mention Microsoft Access here because one of the types of geodatabases that we work with is called a personal geodatabase, and so the attributes are stored within the confines of an Access database. And we'll look at that here in just a few minutes within the context of Arc Catalog and in Arc in Windows Explorer. What does a geodatabase look like on disk? Again, I'll jump into our catalog here, but we can see its constituent parts. Here we're talking about feature classes. So feature classes are individual layers, whether they're points, lines, or polygons. So in this case, in our USA feature data set, and again, I've got a label over here indicating that this is a feature data set, and then there's another feature data set. So all of these feature classes are feature classes that are unique only to the USA, versus worldwide data that would be global in scale would be contained within the world geodata set, feature data set in the geodatabase. So this one may look familiar to you from assignment number 2. Some of you did download that and pinged me with a few questions and said, hey, I've unzipped this file and now I've got this folder. What do I do with it? So this is how Arc Catalog perceives it, as the silver canister with a bunch of geographic data inside of it. But what's really key here, before I get to topology, is that we perceive this in Arc Catalog. We're going to go into the USA World Data Geodatabase. And again, there's our 2 feature data sets, and Arc Catalog is very nice to tell us that it's a feature data set. And inside, there are the different layers that make up the feature classes for the United States. In this case, we're looking at a layer that is counties for the entire United States. I'm going to come back to this GDB folder and look at the contents again, because you'll notice that the World Data USA World Data Geodatabase is a file geodatabase. So we'll talk about that here in just a second, versus our example for a personal geodatabase. For the city of Fort Worth, there's a fire department feature data set. So again, you would group data according to maybe a theme. So maybe you would have a police department, Department of Public Works feature data set that would store data that is unique to that particular department. So that's one option in terms of organizing your data. So all of these represent different types of fire associated features within the city of Fort Worth. So again, coming back up to the geodatabase folder here, we've got what's called a personal geodatabase, and you can see the file extension is not the same. We've got GDB here, geodatabase, but MDB is the file extension for Microsoft Access, so Microsoft Database essentially, whereas here we're saying geodatabase. They're both geodatabases. We can see that here over on the right hand side, but one is a personal geodatabase and one is a file geodatabase. Not much difference here, 2 silver canisters, they're just named differently, but how do they look in Windows Explorer? Well, if we were to go into that folder again, into the GDB folder, we'll see that the USA World Data GDB looks significantly different than the city of Fort Worth. You do see the lock file here because, again, I have that same data opened up in Arc Catalog, so a temporary lock file is listed in there. But this is the geodatabase for the city of Fort Worth, and remember we said that it is a personal geodatabase. Personal geodatabases use Microsoft Access as the storage mechanism, if you will, the relational database management system, the storage mechanism for the attributes. All right, so all of your attribute information is stored within this access database, but all of the geometry and everything is also stored in that file as well. So it looks like an access database on disk, whereas in reality it is an actual canister of geographic data. So be very careful, not necessarily to open this kind of data in Access and to manipulate it, because you could corrupt your data. And the other side of the coin here is that we've got a file geodatabase, and a file geodatabase basically stores the geographic data in a set of folders and files. So if we were to go into the USA World Data Geodatabase, which I would not recommend, and I know some of you guys might have done this as part of the first assignment by accident. As long as you didn't put anything in or take anything out, you did not corrupt it. But again, this is the guts. We're looking at the guts of the data here, and we do not want to interact with this at all in Windows Explorer. That is all the data that ArcCatalog and ArcMap reads to be able to create your digital data, your GIS data, your spatial data, and your attribute data that is used within ArcCatalog, within ArcMap. So if I were to go in here and again go into the US layer, look at US cities and preview it, I can see the actual point data. I can come down here and I can also preview the tabular data as well. All of that in this case stored within that folder. Whereas with the city of Fort Worth, if I were to preview a particular layer, let's just look at battalions. These are polygons representing different battalions within the city of Fort Worth. That's the geometry, that's the polygons, and then of course the table is going to contain some sort of information about those different battalions across the city. So a word of caution, but it's mostly to give you familiarity with a lot of the formats that you're going to use here. So the last thing I wanted to talk about with regard to vector data is this concept of topology. Now our definition says the mathematical science dealing with the relationships between points, lines, and polygons. So that relationships term is going to be very important, because as we start to query our data in a couple of weeks, we start to learn about how we consider how layers relate to one another. Case in point, we might have an analysis where we want to try to find out how many point locations of underground storage tanks that are leaking fall within a polygon of a 200-foot buffer around streams. That's just an example off the top of my head. So we're talking about what I'll now start to call topological relationships, the spatial relationships between the different layers, whether they're points, lines, or polygons. And so the key here in this discussion is that shapefiles have no topology rules. You can do a lot of dangerous things with shapefiles, and you need to be careful with that. So I'm going to jump out of here really quick, and I'm going to use an example of property. I'm going to jump into my little pseudo whiteboard here, and I'm just going to draw a polygon. And again, this is not GIS data. This is me sort of graphically sort of drawing up on the board like I would in a class. And I'm just going to sort of divide this into two pieces. And let's just imagine that these are two properties. This is Jamie's property over here, and this is Scott's property over here. In reality, in the real world, property lines do not overlap in any way. So if I step over this line, I'm on Scott's property. Over here, Scott steps over, he's on my property. In a GIS, when we model this in a vector environment, we sometimes need to edit the data. And we could, in a shapefile, very easily accidentally start to draw and extend, say, Scott's property over into Jamie's property. And so in reality, what might happen is I may have sold some of my property to Scott and given as part of that transaction that land over to him. But if I'm not conscious of how I manipulate the data, I could have created an overlap between these two layers. So now the new area that's calculated for his property is correct, and the area for my property is represented by the original square is incorrect, because basically we've created an overlap between these two properties. We would want to move the two adjacent lines, and we'll learn how to do that as we move on throughout the class, and we would want to be able to have our data kind of look like this. And this is me sort of mimicking what I would do on a whiteboard in a class. So this is our ideal situation where this would be our new property line moved within the data. So we want to be mindful of that, and we control that with topology in geodatabases, but in shapefiles, there's no real control over this, and that's what I mean by topology rules. There are no real topology rules with shapefiles. You can't really control that, so you got to be very careful when you're doing editing, especially when you're doing polygon editing. Coverages, on the other hand, would handle it on a single feature type basis, whether they were points, whether they were lines, or whether they were polygons. So I like to use the example. I'm going to just go ahead and delete this. And I'm going to use the example of a road network. So I'm going to draw some lines here that represent a basic road network. And I don't need to be too perfect or make this too pretty, but you guys get the idea that I'm drawing maybe some downtown roads, and then here's another road that kind of comes in. So the way ArcInfo would handle the concept, if you will, of lines, lines must not have dangles. So what we mean by that is that lines can't just end like this. They need to connect somewhere. So I'm just going to kind of draw what we used to call node dangles, what we used to call these different errors. Now, in a road network, we would want these connections where road intersections occur to not have errors either. But if for some reason, as we were editing the data, let's just say I undershot this right here, I might actually see another error. Bear with me. I'd see another error generated right there. That would be an error because that road actually connects to this perpendicular road and to the road as it continues on. These are all treated as separate individual segments. However, so we take it back and we don't have an error there simply because those are all connected. So why do we have errors here? Well, ArcInfo for lines basically had a wholesale rule that said you can't have any node dangles. Well, these dangling nodes could actually be cul-de-sacs, or they could be the ends of a stream network. Okay, so we're using the example of roads here, but we could just as easily model a stream network. And so these are what we would call acceptable node dangles. But again, a single geometry type is what we're representing here. And so that's how ArcInfo handled it, sort of on a feature type by feature type basis, whereas the geodatabase gives us multiple topology rules, and that's where the power of the geodatabase really comes in. And again, not necessarily utilized as part of this course, but I did want to hit this poster. I'm going to go ahead and open up this PDF online, which allows you to control the integrity of the data of your points, lines, and polygons within your data. Waiting for that to come up here. Let's see. Oh, there it is. I just had it. Bear with me. Where are you? There you are. So what we're looking at here is a poster that has several different examples of different rules that are sort of preloaded within the software that let you model behavior between the layers. So for example, I like using this contains one point rule as an example. So you can see the different parcels. Let's imagine that these are property parcels, and so you could have a data set that represents the area of the parcel, but you could also have a point that represents the centroid or just the front address of the building. And of course, points are going to be much smaller files than polygons on disk, so sometimes it might be better to work just with the points. A topological rule may say you can't move those points outside of their constituent polygons or their related polygons, because that's a violation of the topological rule. Each polygon must have its corresponding point inside of it. If you were to edit the data and move one of those points outside, it would give you an error to say, hey, you've created a violation of a rule here. So take a look at all of these different rules. It's not necessarily something that we're going to dive into in this course, but it's something that allows you to control the integrity of your GIS data, and something that is a very important part of our discussion as we talk about these different formats and some of the functionality that all of these formats have. So our next step from here on is for you guys to review this lecture, take a look at the videos a couple of times, because now you got to move on to the quiz that you're going to be taking as part of the data formats module.